We're going to be dividing polynomials using synthetic division. So that sounds crazy right now, but it's going to be your best friend by the end of the day. So like it was said earlier, we're going to be using long division today. So let's practice real quick a long division problem. How do we divide 265 by 2? Yeah, first we have to look at this number here and we have to say, all right, how many times does 2 go into this first digit? How many times does 2 go into 2? 1, right? And then we multiply 1 times 2 and then bring it right down below here. And then do you guys remember what we have to do with these two numbers? Yes, good. Subtract. Alright, we have to subtract those. So 2 minus 2 is going to be 0. And then since 2 can't go into 0, we have to bring down the next digit, which is 6. So I'm going to bring the 6 down here. And then how many times does 2 go into 6? Good. 3. So then we multiply, we do the whole process again. 3 times 2 is going to be 6, and then 6 minus 6 is going to be 0 when we subtract, right? Now since 2 can't go into 0, we have to bring down the next digit, which is 5. So when we bring the 5 down, we see, okay, how many times does 2 go into 5? Now 2 doesn't go into 5 evenly, right? But it does go at least in twice. So then we multiply. 2 times 2 is going to be 4. When we subtract, we get 1. Okay, and so then we get our remainder, which is going to be 1/2. Now notice, where did I get this 2? I got this 2 from the divisor, which is this guy right here. Okay, so the remainder, which is the 1, goes on the top of the fraction, and then the 2 goes right here. So why don't you guys take a second and try dividing 8 into 7,689. Okay, let's go over this. So 8 doesn't go into 7, so we're going to have to skip a decimal or skip a spot, and we're going to have to move over to the next. 8 goes into 76. We see it goes in 9 times. We multiply. 9 times 8 is going to be 72, and then we subtract. 76 minus 72 is going to be 4. Now 8 doesn't go into 4, so we're going to bring down the next place value, which is 8. Okay, so I got this 8 from this guy right here. 8 goes into 48 6 times. 6 times 8 is 48. It goes evenly, so we're going to get a 0 here, right? And so since 8 doesn't go into 0, we have to bring down this 9 down here. Okay, now 8 goes into 9 how many times? Once. Okay, when we multiply 1 times 8, we get 8, and then we subtract, and we get 1. Now, where does this 1 go? This 1 is going to go on the top of our fraction, right? And now what goes down below is our divisor, which is 8. So we put the 8 right there. Okay, and that's how you do that. So how do you feel about this? Hopefully pretty good. Let's move on to the next slide. Okay, here's our first example, polynomial long division. So notice that the directions say divide, so that's what we're going to do here. We have x minus 5, and it's we have to divide it by this huge trinomial right here. So what you're going to do in order to do this, we're going to first look at this term right here, which is x. Now what do we need to multiply x by to get x squared? Yeah, x, right? So that's going to be our first number that goes on the top. And then, just like what we did with those previous problems, we're going to multiply this number times the x right here. So what is x times x? Sure, x squared, right? But don't forget we have another term, because this is a binomial. We have to multiply this x times the negative 5. So what's x times negative 5? We get negative 5x. Okay, so do you guys understand? See that first step there? Now just like with the previous ones, we're going to now subtract this. Now since we have a binomial that we're subtracting, this we know is going to be 0, but then we have a negative 5x. So we have a double negative, so you have to take the opposite of whatever this term is on the bottom here, okay? Not the first one, but the second one. So that's going to be now a positive 5x. Okay, so 5x plus 2x is going to give us 7x. Now we look back at our divisor and say, okay, how many times, or what do we have to multiply x by to get 7x? And then that's going to be our next term. So, plus 7. Okay, notice that I brought down the negative 30 as well. So, 7 times x is going to give us the 7x, and then 7 times negative 5 is going to give us a negative 35. Now remember what we do when we subtract, we have to take the opposite of this second term. Okay, so that's going to become a positive 35, then we subtract, that's going to be a 0, and then this is going to give us a positive 5. Okay? Now, our x can never be a positive 5 because it needs some sort of variable of x in there. So this is our remainder, the 5. And so just like what we did before, we're going to put the 5 as the very top of the fraction, and then our divisor, which is x minus 5, is going to go as a fraction below. Alrighty? Here's another example of what your classwork and homework will look like. It'll be asking you to check the factors. Notice the directions. It says determine whether x plus 2 is a factor of each polynomial. Now, when you see the word factor, think of like 6 and 8 are factors of 48. So we're seeing if x plus 2 and something else will multiply together and produce this trinomial here. So basically, what we want you to do here is divide x plus 2 and this trinomial here, x to the second power plus 10x plus 16. Now there's a shortcut to this though, okay? To see if it's an actual factor, it should go in evenly and there shouldn't be any remainders. Okay, so what we can use here is the x. Do you guys remember the x? Of course, right? So at the top, we see a times c, so we're going to put 16 up at the top, right? On the bottom goes 10. Now, are there any factors of 16 that would add up to give us 10? Well, of course, 8 and then 2, right? So then that means our two factors, when we write it out in factored form, are going to be x plus 8 and x plus 2. And we see certainly that x plus 2 is a factor, so you would say yes there. So let's try another one. Let's look at this. Now notice this is not necessarily in standard form for a regular quadratic that we could use the x. Okay, so what we do have to do here is we have to divide like what we did in the previous screen. Okay, so the x, it doesn't work here. It's not going to work. So let's try dividing right now. Take a second and you guys divide x plus 2 into this quadrinomial. Now when you divided, this is what I got. Now notice that you ended up with a remainder. Now since you have a remainder, that means that it's not a factor. It doesn't go in evenly. So you would conclude that x plus 2 is not a factor. And isn't that crazy? Look at this. It says f, that's supposed to be factor there, and so is this. I just noticed that right now. Crazy. Anyways, next example. So here's a quick check. If you guys have any questions or you're not too sure if you want to extra practice, go ahead and take a couple minutes and pick one or two or all of these problems here and try it out for yourself, see if you got this down. Okay, number 1 is what I got, x plus 1 and then remainder 5. So remember that we put the 5 over x minus 4. The book does it this way, but we're going to be doing it the other way. Number 2, yes, it is. And then number B, that's a number, yes, B is no. So let's move on. This is the best part of the lesson, so you guys are going to love me after this. Just trust me. Stupid fly. Alright, so example number 3, it says using synthetic division. Use synthetic division to divide, and then it gives you this huge long number, and then you have to divide it by x minus 3. So normally, this is how we would do this, right? We would put it in this format, and then we would try to divide it, and it takes a long time, and it's kind of confusing. So I'm going to show you a shortcut, which is called synthetic division, and it's so much easier that you guys are going to be so happy that you're going to go out and buy your parents like an awesome gift for Christmas. I mean, today, that's what you're seriously going to do, I promise. Okay, so this is what we're going to do. Number 1, we have to set the divisor equal to 0. So now what is the divisor? Anybody know? Yeah, it's going to be the x minus 3. So let's go ahead and do that. Let's set that equal to 0, and we're going to solve. So basically what we're doing is you're going to add 3 to both sides, and you're taking the opposite. So x equals 3. Now that's going to be our little magic number that's going to go in a little box like this. Okay? And then step number 2, what we're going to do is we're going to use the coefficients of the quotient. Okay, now the quotient is the thing that's underneath the divisor bar. So could you guys identify all the quotients that we see there? Now don't forget, a quotient also has the sign. So the first one we see is 5, so it's going to be a positive 5. The next one we see is a -6, okay, and then after that is 4 and then -1. So we're going to bring those guys down right there. Okay, so the 5, the -6, the 4, and the -1. Okay, this is the best part right here. So all you're dealing with is the opposite pretty much of the divisor, and then you're going to take the coefficients of the quotient. Okay, then we're going to draw a little line. Okay, and we're going to bring the first coefficient down, which is 5. Bring that guy down. Okay, and then I'm going to multiply by my divisor right here, this 3. So I'm going to take the 3, I'm going to multiply by the 5, and that number I'm going to put right up top here, which is 15. Now I know that sounds confusing, but once you get the hang of it, it's going to be really cool. Alright, and then we just simplify here. 15 minus 6 is going to give us 9, and then we're going to do the same process over again. Okay, we're going to repeat until the very last coefficient, the -1. So I go 3 times 9. What's 3 times 9? It's 27, so the 27 goes right there. And then we combine these here, right? 27 and a +4 is going to be 31. Now we do this again. 3 times 31 is going to give us kind of a big number, 93. Okay, and then we subtract here. So 93 minus 1 is going to be 92. Now these numbers, these are going to be the coefficients, and this last number is going to be your remainder. Okay, so the last term is your remainder, this is your constant term, and then this is the term that has the x, and this is the term that has the x squared. Okay, so remainder's there. I got 92. Now why did I put this over x minus 3? Because remember, that was originally what we had right here as our divisor. Okay, and then 31 is going to be right here, and then that's our answer there. So what do you guys think? Piece of cake, right? A little bit easier. Let's go ahead and try one yourself. It says use synthetic division. So you guys try this one here. Okay, first what I'm going to do is I'm going to take this x plus 1 and set it equal to 0. So x plus 1, set it equal to 0. We subtract 1 from both sides. So my magic number is going to be -1. So the -1 goes right here in this little box. Okay, then I'm going to take all my coefficients for all of the terms here and the constant. Okay, so this is going to be a 1. This is going to be a 4. This is just 1. And this is a -6. Okay, then I'm going to draw my line, and then do you guys remember what the first step is? Yeah, we're going to take the first coefficient and bring it down here. Okay, now we're going to multiply. -1 times 1 is going to be -1. Okay, and then we combine these to get 3. And then -1 times 3 is going to be -3. So that's where I put that. And then this will simplify to be -2. -1 times -2 is going to be a +2. We put that right here, and we combine these to get -4. Okay? So remember, this last number is going to be our coefficient. I'm sorry, did I say coefficient? Just kidding. The last number here is going to be our remainder. So I'm going to take -4, I'm going to put that over our divisor, which is x plus 1. Okay, so that's our remainder, and I'm going to bring down, since this is negative, I can make this a positive and just bring the negative down here. Okay? So the negative is right here. Whatever this sign is here, you put it right there. And then I've got a -2. Okay, that's the constant term. Now this is going to be 3x. And then this term right here is going to be just the x squared. Okay, depending on how many terms you have, you just start at the constant, then the x squared, then you go up to x cubed, x to the 4th, and so on and so on. Okay, so this is our answer right here. I want you guys to notice something, especially when it comes to the test. Whatever you're dividing by, whatever the degree of this, if it's a polynomial, if it's a 3, then this leading coefficient is always going to be smaller than that. Okay, just like if you're going to divide 6 into 12, your answer is never going to be bigger than 12, right? It's not going to be like a 14. That just won't make sense. Okay? So that's how you use synthetic division. Let's go on and let's check out our classwork. Okay, so here's the answers to the classwork. If there are any questions that I wasn't able to address And go ahead and circle them, and I'll be more than happy to get to that next time I see you.